All right, let's take a look at some notes here for section 4-6, congruency of right triangles. So what we're going to see today are two right triangles, and we're going to add one more way to prove triangles congruent, but in particular right triangles. So we've already seen side, 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 angle, side, angle, and angle, angle, side. We're going to add one more, but again, it has to be a right triangle. A few things here with the right triangle. The hypotenuse is opposite the 90 degrees, the right angle. It is the longest side of the right triangle. So if this is the 90-degree angle here, you go across that 90 degrees, this is the hypotenuse. And the other two side lengths of the right triangle are called legs. I mean, you can obviously just call them sides, but they are also called legs. All right, so here is this new formula, and instead of SSS, SAS, it's going to be HL, which stands for hypotenuse and a leg. If the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the two triangles are congruent. Before you use hypotenuse leg, you must state that the two triangles are right triangles. Okay, so somewhere along the proof, if you want to use hypotenuse leg as opposed to side, 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 or side, angle, side, you're going to need to state that you're dealing with right triangles, because the only triangles that have a hypotenuse are right triangles. All right, so let's go with our one proof here. We are going to, of course, figure out why two triangles are congruent. Now, these two triangles at the end here will be right triangles. And there's a lot of triangles in this picture, but you need to just focus on the big right triangle at the bottom and the big right triangle on the top. We're not concerned with this triangle here or even this little isosceles triangle. All right, let's go with the given. Angle ABC and angle DCB are right angles. That's part of the given. Now, what does that lead to? That makes triangle ABC and triangle DCB right triangles. If you have a right angle, you create right triangles. We'll say definition of right triangles. A right triangle is going to have a right angle. So step one mentioned there's a right angle, so that means these must be right triangles. All right, so that's going to be critical because later on, now that we know that these are right triangles, we're going to use hypotenuse leg. And again, hypotenuses are only in right triangles. Let's go on. Step 3 here. AC is equal to DB. That's in the given right there. And if I look at the picture here, AC and DB. So this is AC here, this orange line, and DB here. These orange lines are congruent. Now, if I pull them out and I look at the triangle, this one, that's this tick, that's BD, and then if I kind of separate the two triangles, this is the other one, that's CA. These, yes, they're sides, but in particular, they happen to be the hypotenuse, H, because these are right angles and they are opposite the right angles. So those orange lines there are the hypotenuse. We're going to need a leg here. And then it says something, something, and then reflexive property. Well, what side is being used in both of the right triangles? It would be C to B, C to B. So that's what we're going to say. CB is equal to CB. And that's this tick here, tick, tick. And you need to realize that this is reflexive property. This is not a side. This happens to be a leg. And so now we got enough to prove that the two right triangles are congruent, and we're just going to go with hypotenuse leg. Okay, hypotenuse leg. Now that's only two pieces, but really it is three pieces, because normally we've always had three pieces. 1, 2, 3, side, side, side. 1, 2, 3, side, angle, side. And then you would say, oh, okay, hypotenuse leg, that's only a two-piece, but because they're right triangles, we pretty much have a congruent angle. So we have an angle, we have two sides as well. Now why can't we just go side, angle, side, or use side, side, angle, or anything like that? Well, because in particular, this is a right angle that's equal, that's an A. There's a side length that's equal, S, and another side length equal S. and as does not work. But because that angle is a right angle, we can use hypotenuse leg instead.